Welcome. What you are about to watch is not science fiction, and it is not folklore. It is a serious investigation into one of history's most compelling unresolved questions: the mystery of Siberian craters, the explosive permafrost holes appearing across Russia. Across the world, in universities, research institutes, and field excavations, serious scholars are wrestling with evidence that does not fit the accepted story. Evidence that has been documented, measured, and peer-reviewed, and that still has no satisfying conventional explanation. We are going to look at that evidence carefully, without prejudice in either direction. Not dismissing what is extraordinary, but not accepting it without scrutiny either. The truth, as always, is in the details. In July 2014, helicopter pilots flying over the Yamal Peninsula in western Siberia spotted something that should not have been there. A perfect circular hole in the ground, approximately 30 meters wide and 70 meters deep, with walls of frozen earth and a water-filled bottom. There was no meteorite, no mine, no explanation from local authorities. Within months, researchers who examined the crater found something that put it in a different category from any geological feature previously documented in the region. Methane concentrations at the crater rim were 9.6% of air volume. Normal atmospheric methane is 0.00018%. The crater had been formed by an explosion of frozen methane from beneath the permafrost, not a slow geological process, but an eruption. Something underground had built to pressure and detonated. By 2023, over 17 large craters of this type had been confirmed on the Yamal and Gydan peninsulas, with hundreds of smaller collapse features identified by satellite. The rate of new crater formation is accelerating. The mechanism is understood. The Arctic is warming approximately 4 times faster than the global average. Permafrost, that has been frozen for thousands of years, is thawing. Methane locked in ice is building to explosive pressure. These are not distant theoretical tipping points. They are holes in the ground that opened in less than a year. The question now is not whether this is happening, it is how fast. This is where our investigation begins. Stay with us, because the further we go into the evidence, the more extraordinary it becomes. The story you think you know is only the surface. Beneath it lies something far more remarkable. Let us begin. Before we examine the specific evidence, we need to step back and understand the context. This case does not exist in isolation. It sits within the expanding frontier of unexplained cosmic phenomena, and to properly evaluate what we are looking at, we need to understand the broader picture that surrounds it. The scale of the universe is so far beyond ordinary intuition that even physicists struggle to hold it in mind. The observable universe contains an estimated 2 trillion galaxies, each containing hundreds of billions of stars. The Milky Way alone has between 100 and 400 billion stars. Conservative estimates suggest that 1 in 5 of those stars has a planet in the habitable zone, the orbital range at which liquid water can exist on the surface. That gives our galaxy alone somewhere between 20 and 80 billion potentially habitable worlds. Against those numbers, the claim that Earth is the only planet to have produced intelligent life seems extraordinary. The statistical argument for extraterrestrial life is almost overwhelming, and yet we have no confirmed contact, no artifact, no verifiable signal. The contrast between the mathematical expectation of abundant life and the apparent emptiness of the cosmos is the Fermi paradox, and it is one of the deepest unsolved problems in science. The paradox has generated dozens of proposed solutions. From the Great Filter hypothesis, some catastrophic barrier prevents civilizations from becoming spacefaring, to the zoo hypothesis, they are watching us, but not yet making contact, to the simulation argument, the universe we observe is itself an artifact. None of these has been confirmed. All of them have troubling implications. The Fermi paradox is not a curiosity. It may be the most important question the human species has ever faced. This context matters because it tells us something important. What we are about to investigate is not an isolated curiosity. It is part of a pattern that researchers in multiple fields have been independently documenting for decades. And patterns in science demand explanation. With that foundation in place, let us now turn to the specific case at hand. Now we reach the heart of the matter, the core evidence surrounding Siberian craters. The explosive permafrost holes appearing across Russia is more extensive, more verified, and more troubling for conventional explanations than most people realize. Let us walk through it systematically, fact by fact, and allow the evidence to speak for itself. We are not going to speculate here. Every point that follows is documented in peer-reviewed publications, official archaeological records, or government archives that are publicly accessible. The question is not whether these facts are real. The question is what they mean. Consider this first extraordinary detail. The first Yamal crater, designated C1, was discovered in July 2014 by helicopter pilots on the Yamal Peninsula of western Siberia, Russia. The crater measured approximately 30 meters in diameter at the surface and had an estimated depth of 70 meters. The Yamal Peninsula means end of the world in the Nenets language. It is a remote, low-lying tundra region with some of the thickest permafrost on Earth, extending hundreds of meters below the surface. This single data point, if taken in isolation, might be set aside. Anomalies happen, instruments malfunction, researchers make mistakes. But as we continue, you will see that this is not an isolated anomaly. It is part of a consistent and documented pattern. But that is only the beginning. Researchers also discovered methane concentrations measured at the rim of the Yamal C1 crater shortly after discovery reached 9.6% of air volume, approximately 53,000 times the normal atmospheric methane concentration of 0.00018%. This measurement confirmed that the crater was formed by a methane eruption rather than by meteorite impact, subsidence, or pingo collapse. The explosive release of pressurized methane from beneath melting permafrost is now the accepted formation mechanism for the Yamal craters. Now, a skeptic might propose an alternative explanation for this, and that is entirely reasonable. We should always test alternative explanations before accepting extraordinary ones. The problem is that the alternative explanations, when examined carefully, create more problems than they solve. The mystery deepens when we examine. The craters form when methane hydrates, crystalline structures of methane trapped within permafrost ice, destabilize as permafrost temperatures rise. As the permafrost thaws, the methane hydrate lattice breaks down, releasing gas into a subsurface cavity. When gas pressure exceeds the strength of the overlying permafrost layer, the crater explodes upward, ejecting debris up to 120 meters from the rim. Satellite imagery shows some locations transition from flat ground to crater in under 1 year. This is where the conventional account begins to strain. Each individual fact might be dismissed or minimized in isolation. But the cumulative weight of the evidence is another matter entirely. Perhaps most remarkable of all, by 2023, over 17 large craters of the Yamal type had been confirmed on the Yamal and Gydan peninsulas, with hundreds of smaller pingo collapse scars identified by satellite survey. The rate of crater formation is accelerating relative to the 2014-2016 baseline. Russian and international monitoring teams have established permanent observation programs at confirmed craters and at locations identified by satellite as at elevated risk of future crater formation. Researchers who have examined this evidence have described it as genuinely difficult to explain within the accepted framework. These are not fringe commentators. They are credentialed academics publishing in mainstream journals, raising questions that the field has not yet satisfactorily answered. Then there is the matter of the Arctic warms approximately 4 times faster than the global average due to a feedback mechanism called Arctic amplification. As sea ice retreats, the darker ocean surface absorbs more solar radiation, warming the surrounding land and atmosphere. This accelerated warming is thawing permafrost, that has been frozen for thousands to tens of thousands of years, releasing both methane and carbon dioxide in a self-reinforcing feedback loop. What makes this particularly significant is its independence from the previous points. This is not a case of one theory requiring another. These are separate lines of evidence converging on the same uncomfortable conclusion. Adding to the enigma is this finding: pingos, ice-cored mounds that form in permafrost regions, are sometimes confused with the Yamal craters, but the mechanisms and results are distinct. Pingos collapse slowly as the ice core melts, leaving a shallow, rimmed depression. The Yamal craters are formed by explosive methane pressure events that eject material outward, confirmed by debris scattered around crater rims at distances inconsistent with structural collapse. The distinction is important for accurate hazard assessment in Arctic regions. Taken together, these facts form a pattern that cannot be explained by coincidence, misidentification, or methodological error. Each piece of evidence has been examined by skeptics. Each has been subjected to alternative explanations. And in each case, the alternative explanation falls short of accounting for everything that has been documented. We are left with a body of evidence that demands explanation and an accepted narrative that does not provide one. This is where serious inquiry begins. Now that we have established the evidence, we need to examine the theories that researchers have proposed to explain Siberian craters, the explosive permafrost holes appearing across Russia. This is where the debate becomes most intense, because the theories reflect not just different interpretations of the same evidence, but fundamentally different assumptions about what is possible and what the past looked like. Understanding these theories is not just an academic exercise. Each one has been championed by serious researchers with genuine credentials, and each one captures something that the others miss. The truth, if it is ever established, will likely draw on elements of several. The first major explanation proposed by researchers holds that the Yamal craters are formed by methane hydrate destabilization driven by permafrost thaw, which is itself driven by Arctic warming from anthropogenic climate change. This is the mainstream scientific consensus, supported by direct methane measurement, satellite crater dating, and permafrost temperature monitoring. Proponent: international permafrost research teams and the Global Carbon Project. Main objection: none to the basic mechanism. The debate concerns rate, scale, and whether this process will accelerate to catastrophic levels. This interpretation has significant academic support and is backed by substantial evidence. But it is not without problems. Critics point out that it requires assumptions that go beyond what the evidence strictly supports, and that key predictions of this theory have not been confirmed by subsequent research. It remains contested, and the contest is productive. A rival school of thought argues that some craters previously attributed to the Yamal mechanism may be pingos, ice-cored mounds that collapsed gradually rather than exploded. Proponent: researchers examining smaller collapse features. The pingo explanation applies to some features but not the large craters, where debris ejection distance and methane measurements confirm an explosive origin. Main objection: the largest Yamal craters cannot be explained by pingo collapse. The two mechanisms produce morphologically distinct features. This theory is controversial, and deliberately so. Its proponents argue that the evidence demands an explanation outside the conventional framework. Critics counter that extraordinary claims require extraordinary evidence, and that the evidence presented, while suggestive, does not yet meet that standard. The debate continues in peer-reviewed literature. Perhaps the most unconventional theory suggests that the craters represent a new geological phenomenon accelerating toward a potential tipping point, a gradual version of the clathrate gun hypothesis, in which large-scale methane release from Arctic permafrost triggers measurable additional warming. Proponent: researchers studying Arctic carbon feedbacks. Main objection: the catastrophic sudden clathrate gun is not supported by current data. The observed release is significant but gradual, not the rapid gunfire event the original hypothesis described. What is striking about this debate is not merely that experts disagree. That is normal and healthy in science. What is striking is the quality of the disagreement. Serious researchers, working from the same body of evidence, reaching genuinely different conclusions. That level of fundamental disagreement, when it persists over decades, is a signal that something important has not yet been understood. The question is not which of these theories is right. The question is whether any of them is right, or whether the truth is something that none of the current frameworks has yet been able to capture. The case surrounding Siberian craters, the explosive permafrost holes appearing across Russia, does not rest on speculation alone. What distinguishes this investigation from pure mythology is the existence of documented, physical, verifiable evidence, material that has been examined by credentialed researchers and whose authenticity is not seriously disputed. What is disputed is its interpretation. Let us review the most significant documented evidence as objectively as possible. We are not going to cherry-pick the data that supports a preferred conclusion. We are going to lay out what exists and let you draw your own assessment. Physical evidence supporting this account includes the Yamal C1 crater's methane measurements, 9.6% of air volume at the rim shortly after discovery, are the most direct evidence for the eruption mechanism. This concentration is far above any level explicable by surface biogenic methane or background permafrost outgassing. Combined with the absence of meteorite debris or mining activity, the methane measurement confirms a pressurized subsurface gas eruption as the formation mechanism. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Investigators have documented. Satellite time series analysis of the Yamal Peninsula confirms that multiple crater locations show no surface features in imagery predating the crater by 1 year or less. The transition from flat tundra to open crater is documented in sequential satellite passes. This rapid formation timeline is inconsistent with gradual geological processes and consistent with sudden explosive release. The satellite record constitutes direct observational evidence of crater formation speed. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. On-site analysis revealed. Drone and helicopter surveys of the Yamal crater interiors reveal structural features consistent with explosive formation. Fresh, unstable wall faces showing exposed permafrost stratigraphy and debris distributed radially around crater rims at distances up to 120 meters. The radial debris distribution is the definitive diagnostic feature separating explosion craters from pingo collapse features, where material accumulates at the rim rather than being ejected outward. No pingo collapse has produced comparable debris patterns. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Each individual piece of evidence might, in principle, be explained away. A single anomalous artifact might be misidentified. A single anomalous date might reflect contamination. A single anomalous eyewitness account might reflect misperception. The question is whether all of the evidence can be explained away, and whether the explanations required are more or less plausible than the evidence itself. When multiple independent lines of inquiry converge on the same conclusion, that convergence is the most powerful signal in empirical science. And that is exactly what we are seeing here. We have examined the history, the evidence, and the theories surrounding Siberian craters, the explosive permafrost holes appearing across Russia. But now we need to ask the question that is sometimes overlooked in discussions of ancient mysteries. Why does this matter? What does it mean for us today? It would be easy to file this away as an interesting historical curiosity, a puzzle from a distant past with no bearing on our present lives. That would be a fundamental mistake. The questions raised by this case touch on issues that are directly relevant to who we are, where we came from, and what the human story actually looks like before the period covered by conventional history. The Yamal craters are actively monitored by Russian and international research teams, including the Siberian branch of the Russian Academy of Sciences and collaborating European institutions. The Global Carbon Project tracks Arctic methane emissions as a key indicator of climate feedback loop activity. Satellite surveillance of the Yamal and Gydan peninsulas is ongoing, with new craters identified periodically in imagery review. The craters have become a powerful visible demonstration of permafrost collapse that was theoretical before 2014, observable from above, and documented in real time. The gradual version of the clathrate gun is now confirmed as active. Arctic methane emissions are measurably increasing. The craters are a geological clock whose acceleration rate is one of the most closely watched indicators in current climate science. Furthermore, the tools available to investigate these questions are advancing rapidly. Satellite imaging, ground-penetrating radar, ancient DNA analysis, isotopic tracing, and deep-sea sonar are all providing capabilities that previous generations of researchers could only dream of. Cases that were genuinely unresolvable 10 years ago are now open to new analysis, and the findings, consistently, are expanding rather than contracting the mystery. The investigation continues. New discoveries are being made. New analyses are being published. New voices are entering the conversation from disciplines that were not previously part of the discussion. The answers, when they come, and they will come, will not merely solve a historical puzzle. They will force a fundamental revision of assumptions that underpin our entire understanding of human history and human potential. We have now walked through the complete case of Siberian craters, the explosive permafrost holes appearing across Russia from the historical record, through the physical evidence across the competing theories, and into the modern significance of what remains unresolved. What the story of Siberian craters ultimately reveals is not just a historical puzzle. It is a mirror. It reflects our assumptions back at us, our assumptions about what ancient people were capable of, about how knowledge is gained and lost across the centuries, and about the relationship between what we know and what we merely think we know. The evidence presented in this documentary is real. The questions it raises are genuine. The debate among researchers is ongoing, and that is healthy. Science is not a set of conclusions. It is a process, and the process requires that we remain open to evidence that challenges what we thought we knew, however uncomfortable that challenge might be. If you came to this documentary as a skeptic, we hope the evidence gave you something to think about. If you came as a true believer, we hope the critical examination gave you a more nuanced picture. The truth, as always, lies in the evidence, not in what we want to be true. Thank you for watching. If this investigation sparked your curiosity, please subscribe to the channel. We publish new documentaries every week, covering the full range of historical mysteries that the mainstream has not yet adequately explained. Leave a comment below telling us which case you want us to investigate next. The conversation continues. The investigation never ends.